measurements, units and dimensions. Now, first of all, let us see the measurement. What is measurement? Right. What is measurement? See, it is an object. How to measure the mass of this object? We don't know about the quantity or magnitude of this object. How to measure or how to know the mass of this object? It is compared with the one standard value, one unique value, one unvariable value, one stable value, one constant value. That is called measurement. If unknown value of the substance comparing with the known value, standard value, unvariable value, that is called as what we call measurement. And importance of systematic study of measurements suggested by Lord Kelvin scientists. So, on his honor, with respect of Lord Kelvin, temperature expressed in kelvins. So, temperature SI unit is Kelvin. Right. See, it is an object. ఇప్పుడు నేను నా హైట్ ఎంత ఉందో కొలవాలి అనుకుంటున్నాను. How to measure the height? So, this is the unknown value of the object. This unknown value of the object is comparing with the known value, that is called as measurement. Whatever it is, unknown value comparing with known value, that is called as what we call measurement. So, the importance of systematic study of measurement suggested by Kelvin, so on his honor it expressed in kelvins. We have the units to express the physical quantity. So, according to the expressing the units, these are classified into three types. One is fundamental units, derived units, and another one is relative units. Like this, different types of units are there. Right. So, to measure the physical quantities, those quantities which can be defined or measured are called physical quantities. Mass, length, force, temperature, etc. A physical quantity have numerical magnitude and unit. Physical quantities classified into how many types? Three types. They are, number one, fundamental quantities. These are the basic or base quantities which are independent of each other. These never depends on the other quantities. Example, mass, temperature, length, time, current, amount of substance, luminous intensity. We'll discuss briefly. In detail explanation we will see later. Second one, derived quantities. These quantities are formed with the help of fundamental quantities. Momentum, area, volume, density, torque, work, pressure, force, etc. Supplementary quantities. These are also two physical quantities which are neither fundamental nor derived physical quantities, but these quantities are called supplementary quantities. Supplementary quantities are plane angle and another one is solid angle. Right. Vectors are classified into two types. They are, one is scalar quantity, another one is vector quantity. Which are called scalar quantities? The physical quantities are a physical quantity which has only magnitude but no direction, that is called scalar quantity. Example: distance, energy, work, charge, electric current, temperature, specific heat. These are work, speed. These are example for scalar quantities. Vector quantity, a physical quantity which has magnitude as well as direction, both magnitude and direction, that is called vector quantity. Example: displacement, velocity, acceleration, force, momentum, electric field, impulse, angular velocity, angular momentum. These are all example for vector quantities. Now let us see the systems of measurements. Systems of measurements, there are four types. What are they? FPS, CGS, MKS, and modified MKS, and new method or new system is SI. There are four types: serial number, physical system, physical quantity, length, mass, time, we have the four systems. Number one, F, P, S. Second one, C, G, S. Third one, M, K, S. Fourth one, S, I. SI means System of International. FPS, CGS, MKS, SI. In this, all the first letters indicates the unit of length. First letter F, unit for length. C, unit for length. M also unit for length. Next, second letters in all the systems indicates the mass. Third letter indicates the unit for time, physical quantity. So where F is the foot, F is nothing but foot. P is nothing but pound. S is nothing but second. CGS, centimeter, gram, second. MKS, meter, kilogram, second. SI also same. After modifying MKS, the new method is called SI. SI means System of International. Now let us see the relation among these units. See, relation between foot and centimeter, relation between foot and meter, relation between centimeter and meter. Now, similarly, relation between pound and gram, relation between pound and kg, relation between kg and gram. We'll see. First of all, foot, important area, most important. 1 foot is equal to 12 inch. 1 inch is equal to 2.54 centimeter. Therefore, now substitute the inch value in this. Therefore, 1 foot is equal to 12 into inch value 2.54 centimeter, which is equal to 12 fours are 48, 12 fives are 60 plus 4 64, 12 twos are 24 plus 6 30, 30.48 centimeter. This is the value per foot. See, 1 foot is equal to 12 inch. 1 inch is equal to 2.54 centimeter. After simplification, we will get 30.48 centimeter for 1 foot. We know 1 meter is equal to 100 centimeter, which implies 1 centimeter is equal to 1 by 100 meters. Therefore, 1 foot is equal to 30.48 by 100 meters, which is equal to 0.3048 meters, approximately equal to 0.3 meters. Therefore, 1 foot is equal to how many meters? 0.3 meters. How many centimeters? 30.48 centimeters. 0.3 meters, 30.48 centimeters, inch is equal to 2.54 centimeter, foot is equal to 12 inch. Let us see. Now, here 1 inch is equal to, previous examination question, this is 1 inch is equal to how many kilometers? 1 inch is equal to 2.54 centimeter, we know this is, but we know the relation is 2.54 centimeter, but given question is kilometer, so centimeter must be converted into kilometer. In middle we have the meter, so centimeter, meter, meter convert into kilometer. Centimeter to conversion, centimeter to meter, later meter to kilometer, then we can convert from inch to centimeter to kilometers, right? How to convert this? 1 inch is equal to 2.54 centimeter. 1 centimeter is nothing but 1 meter is equal to 100 centimeters. 100 centimeter is nothing but 10 square centimeter. 1 meter is equal to 10 square centimeter is nothing but 1 centimeter is equal to 10 power minus 2 meter. So substitute 10 power minus 2 meter instead of centimeter. 2.54 centimeter. Centimeter is nothing but 10 power minus 2 meter. Now, 1 kilometer is equal to 1000 meters. 1000 is nothing but 10 power 3 meter. It implies to 1 meter is equal to 10 to the power of minus 3 kilometer. Therefore, which is equal to 2.54 into 10 power minus 2. Instead of meter, take 10 power minus 3 kilometer. Therefore, which is equal to 2.54 into 10 to the power of minus 5 kilometer. This is the value for inch. 1 inch is equal to how many centimeters? 2.54 centimeter. How many kilometers? 2.54 into 10 power minus 5 kilometer. This is the relation between inch, kilometer. Yes, these are all the things related to foot, centimeter and meter. Now, relation between among the kg, pound, gram. 1 kilogram is equal to 2.2 pound. It's implies to 1 pound is equal to 1 kg is equal to 2.2 pound. 1 pound is equal to 1 by 2.2 kg, which is equal to 10 by 22 kg. 2 5s are 2 11s are 5 by 11, which is equal to 0.5 by 11 is nothing but 11 4s are 44, 50, 11 6 5s 11 5s are 55, 11 4s are 11 5s are 11 4s are, what is this, kilogram. For 1 pound is equal to 0.454 kilograms, right? So to express this value in grams, 1 pound is equal to 0.454 into kg is nothing but 1000. What is this, gram. Remove the decimal point, we will get by 1 3 zeros into 3 zeros, gram. 1000 get cancelled, 454 grams. For 1 pound is equal to 454 grams. 1 pound is equal to how many kg? 454 kg. 1 kg is equal to how many pounds? 2.2 pounds. Right. 1 kg is equal to how many grams? 1 kg is equal to 1000 grams. It implies to 1 gram is equal to 1 by 1000 kilogram. 1 by 1000 is nothing but 1 by 10 power 3 kg, which is equal to 10 power minus 3 kilogram. Therefore, 1 gram is equal to 10 power minus 3 kilograms. This is the relation between kg gram, pound gram, kg pound. This is right. Next. Which physical quantity has the same unit? Time has the common unit. Which unit is the common unit? Second is the common unit. Time has the common unit. Second is the common unit in all the systems. Right. Okay, next one. Physical quantities. These are the systems of fundamental quantities. Supplementary physical quantities. We'll see them one by one. Physical quantity. Physical quantity, it has the magnitude and unit. So if it is called physical quantity, that must be consist of the two components there. One is magnitude and another one is unit. So that is why physical quantities are mainly classified into two types. They are, one is fundamental physical quantities. Second one, derived physical quantities. Fundamental physical quantities, derived physical quantities. What is the major difference in between fundamental physical quantities and derived physical quantities? Fundamental physical quantities, these are called as independent physical quantities. Independent physical quantities are called as fundamental physical quantities. Dependent physical quantities are called derived physical quantities. Dependent physical quantities are called as derived physical quantities. These are usually depends on other physical quantities. These are usually depends on the other physical quantities or fundamental physical quantities. Fundamental physical quantities, these are also called base physical quantities. Basic physical quantities. Basic physical quantities or base physical quantities, fundamental physical quantities, independent physical quantities. Yes, what are they? Let us see. First one, serial number, fundamental physical quantities, SI unit, serial number, fundamental physical quantity, SI unit in this. First one, length unit, meter. Second one, mass unit, kg. Third one, time unit. Second, temperature, already we know. Temperature SI unit, Kelvin. Electric current, unit, ampere. Luminous intensity, candela, CD means candela. Quantity of substance, unit, mole. And also we have the another one, name of that, another physical quantities. They are, one is plane angle units, radian. Solid angle, steradian. SR means steradian. Right. These two physical quantities are called supplementary physical quantities. Supplementary physical quantities. These are the fundamental physical quantities. Except these 9, remaining all are called as derived physical quantities. What are the derived physical quantities? What are their units, their dimensional formulas? Remaining we will discuss in next class. Thank you.